We are starting with factoring finally, which is going to be loads of fun. So turn to page 13. And again, these are the class notes. So remember, these are the class notes. If I look up here for day 5. Okay, so let's go for it. It says here that we're going to review a little bit as far as simplifying some of the polynomials that we've done a lot of work with. And here we go. So we are winking and smiling. And I am going to end up with 3a squared plus 7 times a is 7a. And then here, I am going to have negative 2m to the third power minus 12m squared plus 2m. Negative 2 times negative 1 is positive 2, and then hold on to the coefficient. And last but not least, I have to think about all these terms. I'm winking and smiling, but I have multiple variables in one term. So I end up with 4x to the 5th. I have to remember to add these two for the product rule. And then I have a y. Hold on to that subtraction sign. 4 times 2 is 8. And I have x to the third power, and then I have y squared. Okay, so that's just a warm up or really review about distributive property and how to multiply monomial by either a binomial or a trinomial. So what we have here is a huge algebraic concept called factoring. And if you can think back to even 5th grade math or pre-algebra, the idea of finding a factor, a greatest common factor, or a factor is some piece, a basic element of something that goes into something else. So what is factoring? Well, in terms of polynomials and where we're going, it's this. If I factor, what I'm doing is I am separating a polynomial back into a product. Or I am really separating it back into its kind of simpler terms, if you think about it that way. So if I think about, let's see, a binomial, let's look at this binomial for a minute. So if I have 4a squared plus 8a, well, that is in simplest form. I can't combine my terms here. I have an a squared term. They are not like terms. I have an a over here. I have an apple and I have a banana. This is in simplest form. But what I could do is I could remove some stuff. I could remove like something that both terms have in common, if you think about it that way, to try to separate it into its two parts. Just like if I had the number 12, if I think about it that. If I have 12, one way I could factor 12, which is if you think about it, it's a monomial in simplest terms. One way I could factor that is by saying, oh, 4 times 3. Yep, that works. I could also say 2 times 6. I could also say 1 times 12. So these are factors, if you think about it, factor pairs that go into 12. So if I look back here, I can think about, well, is there a number or variable combination that goes into both of these terms? Well, does 4, I could think about my coefficient. Does 4 go into 4a squared? Does 4 go into negative 8a? Well, it actually does, which is kind of cool. So 4 fits into both, and oh, both terms have an a in it. Well, a goes into both a squared and a. So actually, for a, I could actually remove out of this. Now, if I think about, well, what do I have to multiply? If I'm kind of reverse distributing, undistributing, if you think about it. Well, 4a times what is 4a squared? Well, really, if I think about it, a. 4a times a is 4a squared. I'm going to hold on to that. Actually, I take that back. I'm going to make that an addition problem. Okay. So let's go here. Now, let's add. I want to subtract. So then what else, if I multiply something here by 4a to get to 8a, what would it be? Well, frankly, if I just double it, that would be the second term in my binomial that I would multiply by my monomial. So these two things mean exactly the same thing. And I am just finding, if you think about two, like a monomial, and I am factoring out and taking out what they have in common, and I'm putting it to the left. Now, just like a number like 13. 13 we know is a really great number. Some of you, I hope, at home are saying, oh, well, I know 13 is special because it doesn't really have factors, except for one in itself. Hopefully you remember what that's called. Prime. That's a prime number because its factors are only 13 in itself. So the same term can be used to describe polynomials. Polynomials that are in this absolute simplest form that you don't have any common factors are also called prime. And we will find some soon, don't worry. So sometimes it's hard to find the GCF, the greatest common factor. You're probably, again, well versed at finding factor pairs in certain composite numbers like 12 or 24 or 36 that have a lot of factors. But what if it's a pretty high number that have a lot of factors? You have to find like the common factor, which you would have done back in the day, like, hey, find the greatest common factor between 12 and 16. What is the GCF? And when you work in fractions, it's something that you use a lot. You might start going through these, like, well, I know that, let's see, its factors of 16 are like 1, 2, does 3 go into 16? Well, 3 times 3 is 9, 3 times 10, 3 times 9 is 3 times 4, 3 times 12, let's see, 3, does that go into it? Does 4 go into it? Oh, 4 times 4 is 16, so 4 goes into it, right? 5, 6, 7, 8. I think that 8 times 2 is 16, and then we have 16. I could do the same over here. I could do 1, 2, 3, 4, 6, and 12, right? 12 has a lot of factors. And then I could analyze this and decide, well, what's the greatest number they have in common, and I could look at 4. Well, it's kind of similar when you have these more abstract ideas like polynomials. There are several factoring methods that we're going to learn the rest of the semester. Again, this is how to find common factors. It depends greatly on what kind of polynomial we have. We're going to start with the more basic idea by factoring out, again, the GCF. So how we can do that is, one is you look to the coefficient, okay, for all the terms. So if I look up here, make sure you can see that. I looked at the coefficient, right? So if I think about this example, I had coefficients in my basic example. I had 4 and I had 8. Those were my coefficients for up here. So if I think about these, the greatest common factor is 4, right? Now I have to look at the variables. So a variable has to be present. It has to be in all the different terms in a polynomial for it to be part of a factor, or the greatest common factor. If it's present in all terms, then take the one with the smallest exponent. Basically the one it fits into that's going to be the variable component, okay? So if I go back to my example here, I'm just breaking this apart, I had a squared, if you think about it, and I had a. So the GCF this was present in both terms, and I'm going to take the smaller term. So a is in fact what they both have in common. That's the greatest common factor. Now we divide each term by the greatest common factor. And whatever is left over becomes the other factor in the parentheses. So if I combine these two. So I have the coefficient number, I have the variable part, and then I have parentheses. So if I divide each term by the GCF, well here, if I go back here, 4a squared divided by 4a is what? Well, it's just a. And then I have my second term, right? Originally was a squared, right? 8a divided by my 4a, okay? That's why it's important to learn how to divide while you're learning how to factor. So if I think about this, then what I have, 8a over 4a is really just 2, okay? So it can be a little bit of work. Again, you're trying to find the coefficient that they have in common. That is the greatest. The variable that's in all the different terms, put that outside as your monomial, and then in parentheses, start dividing the original term by your big factor to get your binomial terms. Hopefully that makes sense. Biggest thing here is this, is that it is very easy to figure out if you got it right, because you can check your work. Look back here. What's 4a times a? Well, 4a squared. What's 4a times 2? Well, 8a, and that is our simplest form back there. So let's do a couple together. So if I think about my coefficients first, you can write this out if it helps, but you have 3 and you have 12. Well, I think I already know what the greatest common factor is, because I know 3 goes into both 3 and 12. So let's go ahead, and the GCF for the coefficient is 3. Okay. Now, does x, now I'm going to check the variables. Is x present in both terms? It's not. You don't have a variable component in your GCF. So in essence, the only thing that works is 3. So 3 stays outside, okay? And I go back to my original term. So I could even rewrite this as 3x divided by what's outside, and then I could have 12 divided by 3. Think about it that way. I think that might help. So anyway, so I'm just taking the original and putting it over 3. 3x divided by 3, well, that's just x. 12 divided by 3, that's just 4. Okay. And again, I could check 3x plus 12 if I distribute it back out. Sweet. If I look here, I just have 7 as my coefficients, or my constants, if you think about it. Does 7 go into both terms? Absolutely. My GCF is 7. And then I can actually start thinking about this like this. Well, if I already figured out the GCF, that 7 goes into both terms, well, what if I just kind of take a shortcut and I just stick it over 7? That's going to help me in a minute. So take your GCF, put it outside, then the division, what I get as the answer, the quotient to these division problems, will end up being what's in the parentheses. So 7y divided by 7 is just y. Hold on to my subtraction sign. 7 divided by 7 is 1. Okay. Number 3. Okay, so let's think about our numbers first. So I have 8 and I have 36. Well, if I think about, I could just do a quick, like 1, 2, 4, 8. I have got lots. Well, Does 8 actually go into 36? Well, what's 8 times 4? 32, 8 times 5 is 4. Yeah, it doesn't. So does 4 go in? Oh, 4 does. So I already know that 4 times 9. So I'm going to go ahead with my 4. That's going to be my GCF. When you get a GCF, circle it. That's going to go outside. That's my coefficient component. Oh, I have 2 different variables, so I'm done. I can't, it's not like m goes into n. And then I'm going to go ahead and stick that all over the original problem, over my greatest common factor. And then I just turn this into a division problem. So 8m divided by 4 is just 2m. Plus 36n divided by 4 is just 9n. And you're done. Over here, I've got 5. I've got 30. I know that 1 and 5 go into 5. I know that 5 goes into 30 6 times. Okay, so I already have my greatest common factor, so take it outside, put all of this over 5. X does not go into y doesn't go into x, so I don't have any variable component. Let's go for it. 5x divided by 5 is x. I'm adding 30 divided by 6 is, 30 divided by 5 is 6, and then I have y, okay? So this is really good practice. Again, circle, when you get the greatest common factor, circle it. Stick it outside. And then you can, if you see how I did it in these problems, if you take the original problem, put it over the factor, and divide these, right? That will get you the 2 terms you need in the binomial, okay? Hope that helps. Let's go to the homework now. Okay. So the homework's on page 15, and I gotta call it. Okay. Oh, I already like 7 and 49 because 7 goes into 49. And notice a lot of these numbers are purposeful because they fit into each other. So if I think about, if I already feel like I know, I mean, I can write it down. I can say I have 7 and 49. Oops. But I already know it's 7. If one coefficient goes into another, then that's going to be the greatest common factor. And x is not in both terms. So I already know that 7 is my greatest common factor. Put it all over 7. Put 7 outside, get your parentheses, 7x divided by 7 is x. 49 divided by 7 is 7. Boom. I have 8 and 6. Well, they're both even. So I have 8 and I have 6. Again, I could list all of them out if I really wanted to, which I'm happy to do. If it's numbers like 8 and 6, I think hopefully you could tell relatively quickly that they're both even, they're pretty close to each other, so 2 is going to be the greatest common factor. So 2 goes outside, stick it all over 2. And then I have 8m over 2 is 4m, and then I have 6 divided by 2, but it's negative, so negative 3. Again, I can check by distributing. 5a squared, 15, okay, 5 and 15. I already know my greatest common factor is going to be 5. Okay, 5. Stick it all over 5. 5a squared divided by 5 is a squared. 15 divided by 5 is 3. Number 4. I have 12. I have 20. Well, I know that 2, 4, 5, 4, 6. I actually think this is going to be 4. Great. 4. And I'm going to stick it all over 4. 12c squared divided by 4 is 3c squared minus 20 divided by 4 is 5d squared. Okay. 64 and 40. So 64, 40, I could work it all out. I know that 8 squared is 64 and 8 goes into 40. I think that That's going to be my factor. I could keep working out, but I kind of know it's 8. Anyway, 8 goes outside all over 8. 64 divided by 8, well, is 8. 40 AB over 8 is 5 AB, and I'm subtracting, or negative, however you want to look at it. 36 and 24. Ooh, I already know 12 because I know my 12s. That was my spidey sense. 12. 12 goes outside all over 12. Ooh, is there more? Because now I finally have a variable. I have a GCF of A. A goes into A goes into A squared. So I have a variable too. So suddenly I get to have a little more fun. 12A. 36A squared divided by 12A is 3A. 24A over 12A is 2. 18 and 12. That's already going to be 6. So 18 and 12, I already know that the GCF is going to be 6. Now that's my coefficient part. Now I have x, and I have x squared, and I have x to the 4th. Well, I can already tell you that x squared is what they have in common. If you think about it that way. So 6x squared, put all of that over 6x squared, and divide it. So I have 3x squared minus 2. Moving right along, I know that I have 12 and I have 20, and my GCF is 4. I also have a b term. So b is my variable. So I'm going to put all of that over 4b. Sorry, make sure that looks like a b. 4b outside, divide 3ab squared plus 5. Over here, 10 and 5. I already know it's going to be 5. So 10, 5. My GCF is 5. I also have an x, so I'm going to have an x2. So it's all over 5x. 5x goes outside. I've got parentheses. 10x squared divided by 5x is 2x. 5x divided by the same is 1. 14. 21. I already know it's 7. I have x's. Take the lowest number, and that's going to be your variable part. So I have all of it over 7x. 7x goes outside. 7x times 2 minus 3x. Voila, 81 and 48. If you were to do this out, you would realize, I don't know why I did it like that, that your GCF would be 3, believe it or not. And I have an m in both. So it's going to be 3m over 3m. 3m goes outside. I'm going to divide these, and that's going to be 27 plus 16n. I have 8, and I have 56. Ooh, yeah, I already know it's going to be 8. So 8, 56 is going to be 8. And I also have an a, so I have 8a. All over 8a, 8a. And then I'm going to divide. All I have is a b left over, and then I have a 7 left over. I'll do several more. Okay, so now I have, oh man, that's very interesting. For 13, I don't have any coefficients that are visible, at least, right? I have an invisible one. Well, what goes in both terms is really just an a. That's your greatest common factor. And then I'm just going to subtract. That's why I'm knowing the exponent rules and division rules. This is when we're applying all this stuff, right? ab squared plus a divided by a is just 1. It looks like I'm going to have an x here. I see x and everything, just 1. So x is my GCF, all over x, x squared y squared plus xy plus 1. 15 and 30, I'm back to coefficients. Well, I know 15 goes into 30, so 15 is going to be my GCF. And I see that we have an x and a y and everything, so I get to add xy to the fun. So all over 15xy, 15xy, divide 1, they're the same, 2xy. I'm going to do a couple more, and then I got to get home and feed my hungry children and dog. 36 and 14. 48. I already know that I have a GCF of 12 here. And do I have any coefficients? Yes, I have an AB and everything. So AB wins the game, 12AB over 12AB. And I have 3B left over and a 4A left over. I've got 30, I've got 5. I already know those numbers really like 5. So what else? I got an X. I got 2 X's. I got X squared and I've got a Y. Yeah. So I'm putting all this over 5x squared y. 5x squared y is outside. Divide these, I get 6x left over plus 7y squared. And then I have number 18, which is 9 and 30. I can keep writing this, but your GCF is 3. So I'm going to do 3, and then I have some R's and S's. I've got an R in everything, and I've got an S squared in everything. Sweet. So 3RS squared is my GCF. Divide. This is the last one I'm going to do. 3R squared minus 10S. And I cannot do any more. I do wish you luck. This is getting really fun. Best of luck to you.